For today's quiz, we have a packing peanut, and it's attached to a piece of string hanging from the ceiling. I have a plastic rod. It's uncharged, and this is not charged either. Make sure there's no charges left on it. Discharge it. If I were to take a charged rod, and I can rub it with our fur again, and put charges onto this charged rod and take it near to that packing peanut, what would happen? Put your answer down below. All right, there's several responses that we'll normally get. First of all, if it's a charged rod and you have an uncharged insulator, first of all, the insulator is not a metal, so the electrons can't travel where they'd like to go. They're stuck. They're like prisoners. Wherever you put them, they're stuck there. So if a charged rod came near here, nothing's going to happen. It would not be attracted nor repelled. Some students will put that the electrons are going to jump, and you want to let them know that you're not actually going to let them jump. So get rid of that idea. And regardless, some will say it might attract, it might repel. Often their thoughts aren't fully fleshed out, so let them express themselves and see if you can detect some of their misconceptions. Let's actually see what happens. So I'm going to take and I'm going to rip off electrons, and you might have seen this before. You can hear those electrons being ripped off. There's lots and lots of charges on here. Now if I take it next to this packing peanut, you'll notice that it's going to attract and it will pick up some of those electrons. Now it's not like the metal ball, but notice once it picks those up, it's going to repel. In a pretty significant fashion, it will repel this charged rod. All right, let's go for the explanation of this. You can clearly see, first of all, it came towards the rod, then it's going to repel. For our explanation, we'll have our rod here, and I have our packing peanut hanging from the ceiling in this diagram. If I have an uncharged packing peanut and an uncharged rod, as you might expect, nothing's going to happen. I have equal number of protons and electrons in each one of my atoms. The atoms are overall neutral on both. There's no external force, and nothing happens. However, if I charge this rod and I put little negatives, and they're stuck on here, wherever I put them, they're stuck, and put that rod anywhere near this packing peanut, well, the electrons in each individual atom or molecule, which I have represented here, plus for a proton and the electron over on that side. As I have this rod, and maybe I have to use a little work to put it right there, the electrons are going to spend more of their time further on this side of the atom than on this side. And because of that, we would say that each one of these atoms within the packing peanut, and there would be lots and lots of layers, they're going to end up spending more of their time further away. So the distance between the electron here and the electron here is greater than the positives to the negatives here. And because of that, and we know that force electric equals KQ1 Q2 divided by distance squared, distance really matters. And in this case, the force between the positive and the negative has a shorter distance and therefore a greater force. Therefore, it's going to be attracted more than the repulsive force from the negatives to the negatives, which are spending a little bit more of their time on the other side of each and every atom. And because of that, this will simply swing closer to our charged rod. At that point, you can see that two of these electrons off of the rod here will jump on to this insulator, and maybe they stay right on the surface. Regardless, I now have a charged rod minus 2 electrons, and now over here, this overall packing peanut's charge is, we'll say, 2 electrons. Still missing 2 off of this charged rod, but there are still sufficient numbers of electrons to repel the net -2 that I have on the packing peanut. And because of that, they will now repel away from one another. So that's your explanation for this phenomenon.